Here you have an example of Bitbake recipe. This specific recipe installs the tools for eMMC programming. Here you have all the licensing specification for this package. Then you have the source URI. In this case is a script on the local drive. Then you have the other package from which this tool depends on, and then you have the do install function that specify Bitbake how to move this source file or the output of the compiled package in the root file system that it will create at the end of the compilation. So here's again a sequence of steps that Bitbake do. So at the beginning there is the do fetch that I told you about. So it basically gets all the source file, it unpack the source file with the do unpack, it apply eventually patches with the do patch. Then there is the do configure. You know, we said that Bitbake is a make-like tool, so if there is a configure file, it will be launched in the do configure. Then there is the do compile, the compilation step, the build of the package. And then on this other line, there are all the tasks that Bitbake perform to move the package that has just been compiled to the final image. So there is the do install, like the one in the example of the previous slide, that tells where in the root file system put the file related to the package. Then there is the do populate system root that actually take all the root file system of that takes all the root file system on the temporary working directory of YOCTO in what will be the final image. Then it performs other 3 steps of do package where it actually creates packages for all the tools included in the image in order to make possible also to install them later without repeat the fetching and the compilation steps. Here an example of the structure of the Engicam meta layer. What you need to remember is that the Engicam meta layer has a configuration folder with all the configuration files for the different Engicam machines. Then you have a different group of recipes that can be either BSP specific or they can contain software for the connectivity. So in this case, the firmware for the Wi-Fi antenna, and then also other recipes for hardware tests, or in the end, the most important one, and you will see as you will see later, the operative system image that gather all these other recipes to create the final operative system. Another thing is important to know is that if you are developing a Linux distribution for an embedded system, you will also create in the build process a device tree. That is a tree of nodes where the pin out of the processor are configured to work with specific peripheral and active components. Here we have an example of device tree nodes. So we have a pin control. The pin control is another node when you will specify which pinout of the processor will be used to work with that peripherals, and of course there will be defined inside the node also the interrupts. So everything I talked about is inside the Engicam BSP sources. This is open and available on our GitHub repository, that is github.com/engicam-stable. If you do not want to use the BSP inside of a virtual machine, no problem. You can just download the YOCTO sources of the distribution you want, and then afterward, from our repository, add the Meta Engicam layer. And to conclude, remember that if you need any help for anything, just contact our support team at the address support.engicam.com. So the description of the Engicam BSP is now over. Let's just jump into it and start to play with a virtual machine.